Okay, so now we're going to start with some network introduction topics, and I'm going to cover them in really high level bird eye view as a beginner introductory course to networking. Today, networking is a very big deal, and no matter what you do in the world of IT, because computers today are connected. It's not a single computer connected to itself. There are multiple computers that are connected. You're connected to the internet, you're connected to an environment in your home, in your office. It's literally everywhere. So you need to have at least some basic understanding to the concept of how things connect in order for you to get anywhere in IT. I'm going to cover the basics like IP addresses and subnets. Why do you need them? How do they interact with each other? But I'm not going to dive into the math and the things that are behind it that are more interesting to people who are more advanced in the IT world. I'm going to cover the strictly basic in order for you to get started, and I'm going to cover some complementary things like DNS to explain a bit about the other functions that we take for granted in networking and how they operate. And I'm going to wrap it up with a lab where I'm going to connect to a machine and run some commands and show you basically how do you see those things working in real world and on your machine. And this is something you can practice on your computer as well, just so you see that you truly understand what I'm explaining here. So without further ado, some overview about TCP/IP connectivity. We'll start with the concept of how things connect to each other. So TCP/IP is a protocol suite or protocol stack. It's the de facto standard in modern connectivity of machines in the network. And this is the governing protocol. So basically, everyone who is using a modern TCP/IP network, which is everyone, is how they're connecting is using this protocol suite. And for starters, we have the MAC address, which is a requirement for something to connect in the TCP/IP world. The MAC address is a physical address that is permanent. It is an address that is linked to the device that is connecting you to the network. Basically, your network card has an address that is burnt on it, and this is the address that it uses to identify itself to the network. It is permanent, but there are ways to use and alter and modify it, and those are things that are more related to network security. So I'm not going to touch it in this way, but don't take it for granted that it is truly permanent. But that was the concept when it was originated. It needed to be permanent. The second address that we're going to talk about is an IP address. An IP address is a logical address that is configurable. You configure it either manually or automatically using a DHCP server. And this is the address that you're using logically to communicate. So basically, the combination of a MAC address and an IP address together is what allows you to communicate in a TCP/IP network. Another very networking is subnet. And a subnet is mandatory when you configure an IP address, and it's basically an address that gives you the scope. What is the machines that are in my network, my local area network? What is connected to me or close to me? And anything that doesn't fit in your subnet is something that is outside your subnet, meaning it's outside your local network. It's something that is outside the network, and you need to communicate to it using a different method. And the different method is basically in the next bullet, which is the default gateway, which is an address for a network device, typically a router or devices of that nature, that is able to help you leave your local environment and connect you to other environment outside your home or outside your local office network. And this is something that if you have an home environment, this is your router that connects you to the internet. If you're in an office environment, it comes in other shapes and sizes, but it is a router typically. In order for anything to communicate in this TCP/IP world, you need to have at least the bare minimum of a MAC address, an IP address, and a subnet. And this is how you can use those three in conjunction to communicate. So a little bit about IP addresses and subnet mask and how they interact with each other. I'm not going to go into too much detail here because this is an advanced topic, but what I do want you to know is that each IP address or a subnet mask has 4 octets, and an octet is basically those little red boxes that is divided by a dot. The IP addresses can be anywhere from the number of 1 or 0 to 255, and this is the number in each one of those octets. And the combination between the IP address and the subnet mask is what tells the machine what is the network ID that it's sitting on and what is the host ID that it has in this network ID. I'm going to cover this topic in a much later video, but for now, just understand that this combination is what tells the machine who is local to their environment, who is in my LAN, and who is external to my environment, who is outside in my WAN. So there's a few things additionally in networking that is important for you to cover. One of them being DNS and another one being DHCP. And DNS is something that is very important for the modern world, and this is referring to the concept of names and name resolution, to be precise. So every time you use a machine, you're usually not going to enter IP addresses when you want to reach another machine, or you're not necessarily going to use IP addresses. Almost of the time you would like to write something like google.com or something like server1.local or server1 or server5 dot something else. And those addresses, those names are basically translated behind the scene to IP addresses. And these are the things that you need to be aware of. The service that is responsible for this is the DNS service. And this is something that you need to be aware of when you're talking about name resolution in general. When I refer to configuring DNS server, this is not mandatory when you configure your network connectivity settings. But if you don't have a DNS setting specified, you're not going to be able to resolve any names. And not being able to resolve name is a big problem if you're talking about surfing the internet or even working in a corporate environment where you need to communicate to servers that have a specific name. I'm going to touch some basic name resolution when we're going to do the lab and show you how it looks like and why it should matter for you. Another thing that is important is DHCP, and I wrote it here not because I'm going to talk about it too much, but you need to understand that configuring IP addresses can be manual, which is something that is less common the bigger the environment, or it can be automatic. When we're talking about automatic, we're talking about DHCP, which is a service that provides networks and the devices in the network with their IP network settings and basically delivers the setting in an automated fashion. The way it works is basically leveraging very traditional systems. Every time a machine is booted, a device is booted to the network, it sends a query asking for an address. And basically, it's a broadcast to the network that says, give me an IP address, someone. It's not really pretty, but at the end, when a DHCP server hears this request, it sends a suggestion to use the following IP address and assigns it. Once this IP address is assigned, the DHCP server marks this address as assigned, and then you don't assign it again to new machines. And this is how it keeps order and basically delivers IP addresses in a wide area range.